Hello there, welcome to a second lesson on integration. In the previous lesson, we learned that if the gradient function of a function say y is to x, we can determine the general equation of the function y. In essence, since dy dx is equals to 2x, we integrate 2x with respect to x to get 2x squared over 2 plus the arbitrary constant c, which can simplify to x squared plus c. Therefore, our function becomes y is equals to x squared plus c. Remember, the rule that we are applying is increasing the power of x by 1 and dividing x by the resulting power. In this particular lesson, we'll be learning on how we determine the arbitrary constant c. In general, we can arrive at a particular equation from a general one by finding the arbitrary constant c if additional information is provided. To understand how we are finding the arbitrary constant c, we will take some few examples, beginning with example number 1. Find the equation of a curve whose gradient function is dy dx is equal to 2x plus 3 and passes through 0, 1. Remember, we had mentioned for us to be able to determine the arbitrary constant c, we must be provided with some additional information. And from this particular example 1, such information has been provided, and that is the point where our curve passes through, which is 0, 1, as indicated over here. Now, we will need to first find the general equation of our curve by integrating the gradient function 2x plus 3, and that is going to give us y is equals to 2x raised to power 2 divided by 2 plus 3 x raised to power 1 divided by 1, and then we add our arbitrary constant c. Remember, we are getting that particular result by using the rule for integrating, which involves adding, increasing the power of x by 1 and dividing by the resulting power, and then you add the arbitrary constant c. Now, our general equation will simplify to y equals to x squared plus 3x plus the arbitrary constant c. Since we are told that the curve passes through the point 0, 1, we note that the 0 represents the x coordinates and the 1 represents the y coordinates. Substituting these values in the general equation, we have 1 is equals to 0 squared plus 3 into 0 plus c. And then working out, we find that the arbitrary constant c is equals to 1. Remember, the general equation that you had obtained was y is equals to x squared plus 3x plus the arbitrary constant c. And so by substituting the point where our curve passes through, we're able to find the arbitrary constant c to be equal to 1. Therefore, the particular equation becomes y is equals to x squared plus 3x plus the arbitrary constant, which in this case we found to be equal to 1. Example number 2. We've been told find v in terms of h if dv dh is equals to 3h squared plus 4 and v is equals to 9 when h is equals to 1. So once again, we are required to determine the exact equation whose gradient function we've been provided, and so that will involve us finding the value of c. And therefore, the very first thing that you need to do is to integrate the gradient function so that you're able to determine the general equation of v, which when we do that, you're going to have v is equals to 3h cubed over 3 plus 4h raised to power 1 over 1 plus the arbitrary constant c, which simplifies to h cubed plus 4h plus the arbitrary constant c. So using the additional information that you provided, which is v equals to 9, as indicated over here, when h is equals to 1, we can find what the arbitrary constant c is going to be. Therefore, since v is equals to 9 when h is equals to 1, we substitute in the general equation that we found and solve for the value of c. And so we are going to have 9 is equals to 1 cubed plus 4 into 1 plus the constant c. And that will, when we solve for the value of c, we are going to get c is equals to 4. So therefore, replacing the arbitrary constant c with the value that we found, we are going to have the particular equation being v is equals to h cubed plus 4h plus the arbitrary constant, which in our case becomes 4. Example number 3. A curve whose gradient function is dy dx equal to x squared plus 2x plus 1 has stationary points at y equals to -1. Find its equation. Now, obviously, in this particular question, just like for the first 2 examples that you've done, we'll need to determine the general equation of the grade of the curve, and use the additional information that you've been provided to find the exact value of the arbitrary constant c, and be able to write the correct actual equation of our curve. Now remember, from the topic differentiation, we had learned that at stationary points dy dx is always equal to 0, and therefore we will first need to equate our gradient function to 0, solve for the value of x, so that you're able to determine the point where our curve has those stationary points, because you've only been provided with a single point, which is y equals to -1. We need to find the corresponding value of x, at which points also our curve is stationary. So therefore, equating x squared plus 2x plus 1 equals to 0, we are going to factorize that, factorizing to get x minus 1 in brackets, another bracket x minus 1 being equated to 0, and so we are finding that x is equals to 1. So therefore, the stationary points can be written as simply xy, and we've already found from the working that our x is equals to 1. We already provided the value of y, which was -1, and therefore the stationary point finally becomes 1 and -1. So therefore, this is going to be the additional information that we have and that we can use to determine what the arbitrary constant is going to be. Now we find the general equation of our curve, and it is going to be given by the integral of the gradient function, which will result to y equals to x cubed over 3 plus 2x squared over 2 plus x plus the arbitrary constant c, which again will simplify to y equals to a third x cubed plus x squared plus x plus the arbitrary constant c. Now, as already mentioned, the curve has the turning points at the point 1 and -1. So we shall use this particular point to be able to determine the arbitrary constant c by basically substituting this point in the general equation of our curve, and that is going to give us -1 equals to a third in brackets 1 cubed plus 1 squared plus 1 plus the arbitrary constant c. And solving for that value of c, we are going to have c being equal to -3 and a third. So replacing the arbitrary constant c in the general equation, we'll be able to find the specific equation, which will be given by y is equals to a third x cubed plus x squared plus x minus 3 and a third. Time to put what you've learned to practice. Pause the video and work out the following questions. In summary, in this lesson, we've learned how to determine the value of the arbitrary constant c, which is only possible if you're provided with the additional information. That's all for now. See you in our next lesson.